Thank you for inviting me. This is a very work in progress. I have this result, since a few weeks. I'm not sure what is best to show, not show. So I just put all the results that to me are more interesting, and then you will tell me what you think about. So it's very in progress. I'm gonna start by introducing the topic. So the topic is the interaction between a type of policy, environmental policy called emission permits, and the ECSR, which stands for Environmental and Corporate Social Responsibility. So yes, so I'm sorry, I just would like to get rid of the, I have this stop. I can see the title of my, okay, I got it. Sorry, I am really bad at Zoom. Okay, so the emission trading system, it's the scheme that allocates the emissions right to firms. So firms, if firms wants to pollute, so production is usually polluting, the production brings emissions, polluting emissions, they must purchase the right to do that. What is the idea behind this, this policy is that these permits are tradable. So if you, this is particularly relevant if you have some asymmetry in technology of the firms, because if there is some firms that is more efficient, it might, these permits are tradable, so it might purchase more. You have an incentive to invest in cleaning technology, because then you need to have less, you need less permits, or with the same permits you might, produce more. So this is, I mean, I'm talking as if you know nothing about that. Maybe you are a very expert, so I don't know my audience and just giving very basic details.
It's very useful, Alessandro, to give background. So don't worry. No, I'm not joking. It's really helpful. Thank you.
Some evidence of the relevance of this type of policy. In the US, this was applied to sulfur dioxide in the 1990, and then that was one of the points raised during the Kyoto Protocol in 1997, and it was implemented in the from the EU in 2005, and where there is probably the most developed scheme in the world at the moment. So there is some evidence that this environmental policy is actually applied. So this is one part of the story. So the ATS part. The other part of the story is environmental and corporate social responsibility. The idea here is that some firms might try to focus not just on profit maximization, but also on social concern and environmental concern. Again, there is evidence that people actually do that. Many firms actually do that. So this is what actually happens. In a report from KPMG, it appears that as many as 96% of the world's biggest 250 companies implement environmental and socially concerned practice. And also that the 80% of a sample of 5,200 companies all over the world also do that. What they actually do, it's kind of vague. It could be interventions in terms of technology, improve their technology to abate their environmental impact, but could also be related to improving the focus on consumers, on the well-being of consumers. So the idea, this type of firm objective has been studied a lot in the past decade in several perspectives. Fine, I'm not seeing the... So the environmental and corporate social responsibility has been tackled in different ways, but one of the most popular is assuming that firms actually care about profit maximization. And somehow the implementation of a different objective it yields an advantage in terms of profit. Okay, because from the implementation of this objective, these firms gain a strategic advantage vis-a-vis with profit seekers firms, or vis-a-vis with environmental policies. Okay, so this strand of the literature is called strategic corporate social responsibility. Another reason for which, but it's still strategical, for which firms might adopt environmental and social responsibility practice is because consumers might be environmentally concerned, might be socially concerned. And so they might be happier to purchase from ECSR firms. And but we are not going to consider this case in this analysis. So we are going to assume that consumers don't care about and the environment, don't care about social problems, and so this might nowadays it might be considered kind of a strong assumption, but the results don't really depend on that. This choice would be just to simplify the analysis and to focus on the strategic interaction among firms and the environmental policy. So the last point is there any interaction between environmental and social practices from firms and the adoption of ETS? It appears that there is some interaction. In particular, there are some contributions that show a positive relationship between the introduction of the an ETS practices of an ETS policy and the increase of environmental and social practices. Okay, so some evidence says so. There is also evidence that shows ambiguous effects or no effects at all, but still is something that empirically has been tackled. And curiously, instead, this point has not been investigated theoretically. Okay, so I thought it was a good idea to develop a theoretical investigation, of course, for policy purposes also, to see how the introduction or the also the design of the ETS policy might affect the decision of firms whether to implement environmental and social concerned practice, and what eventually this brings about in terms of welfare, generally speaking. So this is kind of the scope of the present paper. The literature to which this work is related is mainly threefold. I'm not going much in details here. There is literature on evolutionary market structure, which focused, okay, this is a huge literature on evolutionary game theory. Some of this have been applied to market configuration in which some of the firm type were CSR. A second strand of the literature is what I already mentioned, strategic CSR. So the idea that firms might implement ECSR practices to make more profits than the counterpart. And finally, this is of course related to the literature of emission trading system. It's a huge literature. I'm not focusing on all the points, but all the specific problems. Probably the paper is particularly related to those contributions that investigate the optimal number of emission rights. We are not going to look at that, but we're going to see changes in the policy. So we are going to keep the policy as exogenous and see how this change. And also the effects of firms' choice on investment in eco-innovation. So how the equilibrium and then eventually the configuration related to the ATS is influenced, interact with the decision of investing in emission reduction R&D. So we can go to the model. We're going to consider an oligopoly of n firms, greater or equal than 2. Competition is à la Cournot, so competition in quantities. They compete on an unique homogeneous good. As I was mentioning, we're going to have two types of firms, M profit maximizer firms and N minus M environmentally and socially concerned firms. So now I'm actually introducing the static model. Okay, so the first part of the analysis will be static, and then once we get the static equilibrium, we're going to introduce the evolutionary setting, okay, based on the static equilibrium. So we have a super simple demand, so an inverse, a linear demand, given by the summation of the quantity produced by all firms of the two types, and gamma is of course a reservation price. The profit function of these firms is given by, we have fixed marginal cost, so price minus cost times the quantity produced, minus this is the cost of the permits. So EK represents the individual emission of firm K, and A is the price of the emission permits. Okay, so EK is explained on this bullet point. It's given by the difference between the quantity produced and the R&D investment. Okay, so the higher the Z, the lower the emission and the lower the number of permits necessary to produce. Okay, the last part of the profit function is the cost of investment in the emission reduction technology, so which is assumed to be quadratic. Okay, if you have questions, yes, go on.
So here you are assuming that permits are bought on a different market at a constant marginal price, right? So that there is no competition in either the supply or demand for permits.
Yes, no, there is competition. There is one of the conditions that I will show it later is market clearing in the emission permits market.
Okay, so your A, which is the
endogenous.
Ah, okay, okay. Thank you.
It's part of the equilibrium.
Okay, thank you.
Okay. So okay, this is the profit function. So if you are a profit-seeking firms, you want to maximize your profit, like the standard model. By contrast, if you are an ECSR firm, you want to maximize your profit. So this is the objective function of an ECSR firm. Subscript is E, capital. You want to maximize your profits, but then you want to also take into account you care about your emission. Okay, so in your objective function, you want to curb somehow your emission, and your sensitivity to emission is given by a parameter alpha. Plus, you also care for social concern. Okay, so given by consumer surplus, measured with consumer surplus, to which you again appoint a level of sensitivity beta. So I already shown you what E is. Okay, so E is given by difference between Q and Z. Whereas consumer surplus is the standard consumer surplus given by given the assumption of a linear demand function. So other component of social welfare is environmental damage, which is assumed as a quadratic function of emissions. We are going to normalize the parameter to 1 just to reduce the number of parameters. There are a lot of parameters in this problem. The permits revenue, so the gain from the government from selling permits. Okay, this is usually reinvested from at least in the EU, reinvested from some environmental initiative, but we are not going to consider that. We are just assuming that it enters the social welfare function without affecting any other component. So that social welfare is given by the summation of profit seeking, plus summation of profits CSR, plus consumer surplus, plus permits revenues, and minus environmental damage. Okay, so this is, we want to also see the effects on the policy, the practices on the social welfare. So the static equilibrium. The static equilibrium is to be imagined as a two-stage game. Okay, in the first stage, we have, as I was saying to George earlier, equilibrium in the market of permits. We assume the supply of permits established by the policymaker and taken as exogenous in the problem. Okay, this allows you to see how the equilibrium changes based on different values of E bar. And this is, so the supply of permits is E capital bar. So what we want in the first stage is that the overall demand of permits given by the overall emissions equates the overall supply. Okay, so in the second stage of the game, we have the market stage, in which firms simultaneously choose quantities and emission abatement. Okay, so in the static game, the equilibrium concept is subgame perfect Nash equilibrium that you solve by backward induction. Okay, so you usually solve at the market stage. Then, so when you solve the market stage, you take the price of emissions as exogenous, you take as given, and then once you have the market equilibrium values of quantities and investment in R&D, then you apply the condition for market clearing in the market of permits. So this is the way you solve this problem. Going to the solution of this problem, I don't want to stay much here, and just to tell you that in order this equilibrium to exist in interior solution where quantities are positive, emission investment is positive, and the permits of price is positive, we need to put some restriction in the parameter space. And I have to say that some these restrictions, which look not so nice, but they are actually quite standard, qualitatively speaking, in the analysis of ECSR. Okay, so you usually have some range in the sensitivity of consumer surplus to which that allow the existence of this type of market. Okay, if the beta is too low or it's too high, doesn't work. I mean, you do not have some type of firms in the market, or you have some quantity that is negative, so you have to put this restriction. But the good news is that in all this literature, it's kind of like that. So it actually makes one think that it is correct, because it's kind of standard. So once lemma 1 holds, we can get the equilibrium features in the static game. So given by the two quantities of profit-seeking and ECSR firm, the investment in emission reduction of profit-seeking and ECSR firms, and the price of the permits. And to ease the exposition here, I put the price of permits here to determine the level of investment. And you might see that this is actually what determines the level of investment for profit-seeking firms, whereas for environmental and socially concerned firms, there is also the alpha component, so the sensitivity to their emissions. So once we got the static equilibrium, we can turn now on the real interesting part, at least in my opinion, by introducing an evolutionary setting. Okay, so we are going to consider a very large number of firms in the industry. We said M, much larger than N, the previous N. And then in any instant, so here I'm considering a continuous time. In any instant of this economy, N firms are randomly drawn by the M capital firms and selected to play the one-shot game. Then once they are drawn, each firm selects simultaneously whether to implement an ECSR or a profit-seeking statute, and then the criterion for doing that is the expected profit comparison in the static subgame perfect Nash equilibrium. So the idea is that firms choose their statute based on the advantage they get in terms of profit. So eventually firms always care about profits. Okay, this is the point. So firms are Nash players. They observe the composition of their of the rivals, and we are going to denote X like the probability that firms adopt a profit-seeking strategy, and 1 minus X the probability that the firms adopt an ECSR strategy. So X can be interpreted like the share of profit-seeking firms in the market. So basically, the idea is that firms look at the expected profit that they might have in the future periods. Okay. So and in order to do that, so I'm going to show you the expected profit function. Which is given by this this thing. It is quite ugly, but the point is not so intuitively. The idea is that firms take into account all the possible market configuration they might get in the next period. Okay, so this is a bit, if some of you work on evolutionary game theory, the standard model of the basic model of evolutionary game theory, you usually consider a random pair, and when it is applied to oligopoly setting, you consider firms drawn and then put together in a random pair and then play a duopoly. Okay. this is one characteristic, and the second characteristic is that usually they look what happened in the previous period in order to choose what to do, okay, in order to determine their expected profit. Compared to that approach, here instead, we assume that all possible oligopolies, so there is no random pairing, okay? For each firm just assume that it might face on the next period any possible market configuration. Okay, and for any market configuration, they have an expected profit, okay, which is a function of the fraction of profit-seeking or ECSR firm for that configuration. And in this way, they build up their expected profits. The other characteristic is that they look at they are forward-looking, okay, of one period. Okay, so they look at what might happen on tomorrow. Okay, they are not myopic in the sense that maybe they are not fully rational, but they are not looking behind. They are looking on the very next period. Okay, if you have questions, you might ignore. I mean, I put this. The expected profits are not very nice to see.
Alessandro,
yes.
I have a question. What is X here in this formula? The probability?
X is the probability that the firms adopt the profit-seeking strategy.
Oh, okay, I see.
So you might also interpret it as the share of profit-seeking firms.
Okay, thank you.
You're welcome. So the replicator dynamics is based on X. Okay, so in any time there is the comparison, the expected profit comparison, and based on that, we have an increase or a decrease in the share of profit-seeking firms. Okay, I'm going to look at the time. I'm not sure how much I'm talking. Okay, I have half an hour. So as you might imagine, with this type of framework, it is hard to get analytical solution. So what I am actually showing you, it's just a numerical simulation. Okay, so my focus has been on 3 points. One, the stringency of the environmental policy, and two, the level of sensitivity of social concern and the level of sensitivity of environmental concern. And we look at the variation of these three components to see how the market configuration changes and how the social welfare is affected by this difference. So starting with the stringency of the ETS policy, which is, in my opinion, the most interesting part of the results. This is given by the level of E capital bar, so the supply of ETS. Okay, once the government wants to reduce the emission, it reduces the supply of ETS. So you might see an increase of the stringency in the policy by looking these figures in the horizontal axis. We have E bar, E capital bar. So if the lower the level of E capital bar, the more stringent is the policy. Okay, so this is the way to read this. In the first figure, we have the industry configuration. Okay, so in the vertical axis here, we have X, okay, the share of profit-seeking firms. So below this curve, okay, so in this shaded area, we have the share of profit-seeking firms for any level of stringency in the ETS policy. Okay, so for instance, if the stringency, the supply of ETS is 7, then we are going to have about 38% of profit-seeking firms in this industry, and the rest are ECSR. So as a consequence, if the more stringent the policy, and the higher the share of ECSR firms. And this is kind of consistent with some of the evidence that I showed at the beginning of the presentation. Okay, not all of them, because as we've seen, we have mixed evidence. Okay, but much more papers show a positive relationship by the implementation and the application of ETS policy, and an increase in the implementation of ECSR practices. In the second figure, we have the individual emissions of profit-seeking and CSR firms. In particular, we have profit-seeking is this red. I think it's red. I have a problems with my eyes. I cannot tell the colors properly. Daltonism, I think it's called. I'm a kind of that. So I think this is red, okay? And this is green. So the red one is profit-seeking, and the green is environmental and social responsible. I'm putting this figure here because this figure, I think, it helps to understand our results in terms of industry configuration. This is the idea. Basically, you might see that the slope of first off, ECSR firms pollute more, okay, which is per se a counterintuitive result. You say, why then they truly exist if they pollute more? They pollute more because they take into account their environmental impact, but they also take into account consumer surplus, and the consumer surplus more than offsets their consideration in terms of environmental impact. But then again, we might check whether even if individually their environmental impact is always negative than those of profit-seeking, we are still interested in see what happens in terms of market configuration and their impact in social welfare. Okay, so you might notice to understand what happens in panel A, you might notice that the slope of individual emission of ECSR is steeper than the slope of profit-seeking. And so what it means is, if we consider a more stringent environmental policy, the fall in emissions is stronger for ECSR compared, relatively stronger. Okay, because of course they always emit more, but they emit relatively less by going down here. Okay, so it becomes relatively more convenient to switch from profit-seeking to ECSR as the ETS policy becomes more stringent. Okay, so this kind of the effect on the individual emission kind of explains the the change in the industry configuration by reducing the supply of permits, by reducing the number of permits in the industry. The last panel here is just to show the effect of the decrease in the number of permits on price. But this is very intuitive. I wanted to show you, but you might actually imagine that we have for given demand, we have a kind of a decrease in supply, and then of course the price increases. Okay, so you have the lower the bar, so the lower the supply and the higher the price. So that's the standard supply-demand effect that you can get. Once I've shown you this, I'm going to look at the effects on the component on social welfare. In the first panel here, we have aggregate emissions. Okay, so emissions of the groups of all groups of profit-seeking and ECSR. What I want to see is how their pollution of each group changes. And we might see that the overall emissions of ECSR, again, of course, is larger because it's larger individually, so it's larger also in aggregate. We have a decrease in the overall emission of ECSR, but it's not this decrease is not so big, and the reason is because we have yes, a decrease in the individual emissions, but then we have an increase in the number of ECSR, okay, because of that. So the share of ECSR increases. So even if you have a decrease in individual decrease, you have an overall increase of the number of each firms. By contrast, here we have both a decrease of individual emission of profit-seeking and also a decrease in the share of profit-seeking firms. Okay, so this brings about a sharp decrease in in emissions. This overall, okay, this combination of effects brings about a fall in the environmental damage. Okay, so this a green line is environmental damage that decreases with the decrease in the permit, the number of permits, and this, of course, is intuitive. You basically are forbidding to pollute more, and then you have an effect on environmental damage. Interestingly, we have that social welfare increases with the decrease in the environmental damage, which was not obvious a priori. In fact, you see that the decrease in by lowering the possibility of emitting polluters, you are actually reduced. Basically, you are forbidding. You are reducing the possible production in equilibrium, and this has negative effect both on the total profits, which is given by this blue line, and the consumer surplus. Okay, they both decrease. So social welfare, which is represented by this light blue line, increases, and so we might say that the environmental damage is the marginal component to determine social welfare as we have increased when we have a variation in the number of permits. Of course, if you have questions about what I'm saying, please feel free to stop me. Otherwise, I keep talking and talking. Okay, so now I can turn to the second part of the...
You can keep talking, Alessandro, but you have to stop in 10 minutes if you want to have some questions.
Okay. So I'm going to go with the second part of the result, and then I will not show the last because are actually kind of similar to this. So I'm going to see how the equilibrium features change with the changes in social concern, so the beta, the component of the ECSR objective function that cares about consumer surplus. We see that this again, like before, this represents the, there should be an X here that is not here, but so we have in the vertical axis here X. So we have market configuration here, and as beta increases, we have an increase in profit-seeking firms in the industry. And this is kind of the opposite that you usually expect in this literature, because beta is the component that provides the competitive advantage to become ECSR. So this result is quite counterintuitive if you are into this papers, and again might be explained by looking at the difference in the slope of individual emissions. The environmental CSR pollute relatively more, has beta increases, and so this basically give a relative advantage to switch from ECSR to profit-seeking firms. And that explains the steep increase in profit-seeking firms in the industry. Also, the fact that we have an increase in profit-seeking firms that demand less, they need less permits to produce because they emit much less. So this decreases the overall demand of emission permits for given supply. And so the effect is that as in beta increases, we have a decrease in the price of emissions permits. Again, like before, I'm going to show you the component of social welfare. I'm omitting the overall revenue given by permits because it's less interesting, but we might look at that. I thought it was, I'm already showing you too many figures. So, so here we have the aggregate emission by groups. Changes, turns out that changes in beta don't really affect the overall emissions. So we have clearly a decrease in the emissions of ECSR because their number decreases, and an increase in profit seeking because of the same reason. But the overall effect on the environmental damage is irrelevant. So the changes in beta don't really affect the environmental damage, but we have an increase in social welfare with an increase in beta. And this effect is pushed by an increase in profits. Okay, so profits increase with increase in beta, and consumer surplus decrease with an increase in beta. And again, this is really strange for someone who works on strategic CSR. You would expect the opposite. But the reason is because it is true that beta, because beta is the sensitivity to consumer surplus. So you would expect the higher beta and that the consumer surplus would be higher. But you must remember that we have a decrease in the share of ECSR firms. And since we have a decrease, there are less ECSR firms that care more for consumer surplus, but the overall effect is lower because the most part of the firms are profit seeking. And in fact, what you get is that an increase in total profits that is pursued by profit seeking firms. So the increase in social welfare here is motivated by the increase in profits that more than offsets the fall in consumer surplus. So I'm basically what happens with, I'm going to be very quick on the last point. Environmental concern is exactly the opposite, because it has the opposite sign than social concern. So you get exactly the opposite. And like before, is counterintuitive for this type of models. The only thing that is not great is the fact that you might see the slope of the emissions of ECSR is steeper than profit seeking, but this is not very clear. I had to create a figure with a different scale on the left and on the right to show you, because if I show you a figure like this one, you see very parallel, it looks parallel. They are not parallel, but the difference in slope is very minimal, it's not great. But still, to the best of my understanding, this is the only effect that might explain the change in the industry configuration. And again, you have all the result basically inverted. So you have again a switch in the aggregate emissions, but no basically no effect, no changes in environmental damage. And then here you have more consumer surplus because of the increase in, even if the alpha gets relatively bigger than beta, you have the individual, more individual ECSR. So overall, consumer surplus is more considered, and profits are less considered. And And then again, you have the opposite result of social welfare, again, pushed by profits. Okay, so the fall in profits due to an increase in the sensitivity for environmental concern more than compensate the increase in consumer surplus, so that you have a negatively sloped line of social welfare. So to conclude, we have studied the interaction between ECSR practice and ETS policy. The results show that the ETS policy spurs profit-seeking firms to switch to CSR. So, and social welfare is maximized from a stricter policy. By looking at the effect of changes in social and environmental concern, we see that they don't truly change much the level of environmental damage. So they have some effect on social welfare, some interesting effect. It's an interesting effect also compared to this class of models, but it is not particularly, they're an intervention over the level of their level. It's not particularly interesting in terms of the environmental impact. Some discussion might be some limitation related to this model might be related to the fact that goods are assumed to be homogeneous. And as I anticipated, one might think that environmental concerned consumers might be more oriented towards types of like ECSR types rather than profit-seeking types. And the other limitation is given by the fact that I'm not able at the moment to provide analytical result for the evolutionary part of the framework, which is of course that who gives policy and interesting results. So this is it. Thank you very much.